Hey everyone, welcome to another video. This will be the last video for new material on the unit number 10. Okay, so today you'll learn how to divide complex numbers. So complex numbers have conjugates and we call them complex conjugates. So I have here three examples. Okay, so for example, 3 minus 5i, the conjugate of this one is 3 plus 5i. This is 2 plus 4i, the conjugate of this one is 2 minus 4i. This is 9 plus I. The conjugate of this one is 9 minus I. So notice in general, when you have a complex number and you want to find a conjugate, all you have to do is change the sign of the BI part, okay, which is the imaginary number. And also note, if you multiply complex numbers, the I will disappear. So you'll see that on the next few examples. So how complex conjugates work. So I'm going to introduce you on how to multiply them, and so you can see how the I disappears when you multiply them, and then we'll go into dividing complex numbers. Okay, so let me give you 4 quick examples here. So for example, here when I multiply 2 times 2, that gives me 4. 2 times negative I, that's negative 2i. And I times 2, that's positive 2i. And I hope you can see these two are going to cancel, right? And then I times I, that's equal to negative I squared. Don't forget, I squared is equal to negative 1. Okay, so you saw that on the previous lesson. So then as you can see, this cancels. So then this is 4 minus I squared is negative 1. So this is 4 plus 1, which means you get 5. Okay, so when we multiply these two complex numbers, we end up with the I disappearing. Second example, same thing here, negative 3 times negative 3, that's negative 9. Negative 3 times negative 2i, that's plus 6i. And then 2i times negative 3, that's negative 6i. And then negative 2i times negative 2i, that's negative 4i squared. And as you can see, the 6's cancel, so the I part goes away. This is negative 9, negative 4, I squared is negative 1. So then this is negative 9, and negative 4 times negative 1 is positive 4. So then this is equal to negative 5. So again, there is no I left once we multiply those two complex numbers or two conjugates. So for this one here, negative 4 times negative 4, that's negative 16, and I times I is I squared. But then again, this, we know that I squared is equal to negative 1, so then this is positive 16. Again, another example, as you can see that the I disappears when you multiply conjugates, okay? So we're going to use that for the next part. Okay, so for when we divide complex numbers, we multiply the denominator by its complex conjugate. So for example, if you look at example number 4, the conjugate is 1 minus 4i. So then that means we multiply by numerator and denominator by 1 plus 4i. And again, here we're just using the power of number 1. And like I've said before in class, the number 1 is a very powerful number in mathematics, okay? So then I'm distributing 2 times 1, that's 2. 2 times 4i, that's 8i. And then we go to 3i times 1, that's plus 3i. And 3i times 4i, that's plus 12i squared. That's numerator. Denominator. Okay, so when we multiply 1 times 1, that gives us 1. 1 times 4i, that's plus 4i. Negative 4i times 1, that's negative 4i. And negative 4i times positive 4i, that's negative 16i squared. So then we simplify by combining like terms. So we have 2 and 11i plus 3i. Let me just say this here. So this part is 12 times negative 1. Right, which becomes negative 12. So this is 2, 8i, and then let's see, 3i combined to 11i, and this 12i squared becomes negative 12. And then denominator, we have 1, and notice 4i minus 4i cancel. And then we have negative 16, so minus 16, and I squared is equal to negative 1. So then this is negative 12 plus 2, which is negative 10. That's the a value, plus 11i over 1 plus 16. So then this simplifies to, let's see, negative 10 plus 11i over 17. Now, you always try to simplify as much as possible, but 10, 11, and 12, and 17 do not have any factors in common. So therefore, this is the simplest form for that answer. So notice there is no I in the denominator. So your final answer should have no I in the denominator. Okay. Right. Number 5. So for this one here, we multiply. First, let me notice that we have 3 plus 4i in the denominator, I'm sorry. So then we multiply numerator and denominator by the conjugate of the denominator. So that's 3 minus 4i. So then 5 times 3, that's 15. 5 times negative 4i, that's negative 20i, right? Because 5 times 4 is 20, so minus 20i. And then negative 2i times 3, that's negative 6i. Negative 2i times negative 4, that's positive 8i squared, so plus 8i squared. Denominator, so then 3 times 3, that's 9. 3 times negative 4i, that's negative 12i. And 4 times 3i, that's plus 12i. And then 4 times 4 is 16, but negative times positive is negative, so negative 16, and I times I is I squared. Okay, so then we know that this is 15 minus 20 and 6 combined to 26i, and then 8 times I squared, that becomes a negative 8, because again, I squared is equal to negative 1. So this is the denominator, so this is 9, negative 12i plus 12i, those cancel. So this is negative 16 times I squared is negative 1. So then we simplify. 15 minus 8 is 7 minus 26i. And then denominator, we have 9 minus a negative 1, which becomes 9 plus 16. And when you combine 9 and 16, that combines to 25. So 7 minus 26i over 25. Again, see if you can find a factor that goes into 7, 26, and 25, and so you can simplify, but in this case it's not possible. So this is the simplest form for that problem. So again, notice we cannot have I in the denominator, which is why we multiplied by the complex conjugate of the denominator on every single problem. Okay, so for the next example, we have 6i, so then we multiply by negative 6i. That's the conjugate. So the value of a is 0, right? So we just need to multiply by the opposite sign of the conjugate, imaginary number. So then 4 times negative 6i, that's negative 24i. Negative I times 6i, negative 6i, so that becomes plus 6i squared. Denominator, 6i times negative 6i, that's negative 36i squared. But then when we simplify, this is negative, I'm going to write this down, 6 times I squared is the same as 6 times negative 1, so I'm going to bring that to the front, that's the a value, minus 24i over negative 36 times negative 1. That makes that 36 a positive 36, so this is negative 6 minus 24i over positive 36. Now, does 6 go into 24 and 36? Yes. So then this is 6 divided by 6, so that becomes a negative 1. And this is negative 24 divided by 6, that's negative, it goes 4 times, right? So 4i. And 36 divided by 6 is 6. And this is as simple as you can get with this problem. So don't forget, always, always, always simplify as much as possible. Okay, the last example in this video. Notice this has, let's see, 1 over 3i squared means we have 2 of them, right? So for this one, I'm going to do 3 minus I times 3 minus I. So then when I need to multiply by this, I can either, I'm going to do the following. Okay, so this is what I'm going to do. I'm going to multiply first by using FOIL. So I have 1 over 3 times 3, that's 9. 3 times I, that's 3i. Negative 3 times I, that's negative 3i. And negative I times I, that's positive I squared. Okay, so then the 3i's cancel. So then we have 1 over 9. And notice this is I squared, which becomes a negative 1. So it becomes 1 over 9 minus 1, which is let's see for this one. So I had to go back and correct myself. I got carried away because it's 3 times negative I, that's negative 3i. Negative 3 and negative I times 3, that's another negative 3i. But then negative I times negative I, that's positive I squared. So then we have, this becomes 9. This is minus 6i. And I squared becomes a negative 1, right? Because it's positive, but then becomes negative by the definition of I squared. Which I gave you here, and you have that on the previous lesson too. So then let's continue simplifying. So then this becomes 1 over 1 minus 9 minus 1 is 8. So 8 minus 6i. So now notice we have 8 minus 6i in the denominator, so then multiply by the conjugate of this one here, which is 8 plus 6i. Numerator and denominator. And then we multiply again. So 1 times 8 is 8. 1 times 6i, that's 6i. Denominator, 8 times 8, that's 64. 8 times 6i, that's 48i. Negative 6 times 8, negative 6i times 8 is negative 48i. And then negative 6i times negative 6i, that's times positive 6i, that's negative 36i squared. So then numerator stays as 8 plus 6i, but then 48i minus 48i, they cancel. So then this is 64, and we know that this is negative 36 times negative 1, which becomes positive 36. So then this is equal to 8 plus 6i over 64 plus 36, that's 100. And then let's see, GCF of 8, 6, and 4, the highest we can think of here in this case is 2, because 2 goes into 8 4 times, 2 goes into 6 3 times, so this becomes 6i, and 2 goes into 150 times. And this cannot be simplified any further, so this is our final answer for this problem. Well, thank you for watching. I'll see you in the classroom. Bye-bye.